Hello my dear viewers, I'm going to present to you a video lessons about triangle inequalities.
Again, I am Sir Ralph Boris Iquit. That is me. I'm going to have a video lessons on triangle inequalities. The objectives of this video are to state and illustrate the theorems on triangle inequalities and apply theorems on triangle inequalities to determine possible measures for the angles and sides of triangles. Now, what are the triangle inequalities? We have inequality theorems in one triangle and inequality theorems in two triangles. Let us see here the discussions of my students about the triangle inequalities.
Triangle inequality theorem 1. If one side of a triangle is longer than a second side, then the angle opposite the first side is larger than the angle opposite the second side.
Triangle inequality theorem 2. If one angle of a triangle is larger than a second angle, then the side opposite the first angle is longer than the side opposite the second angle. Given triangle LMN where LM is less than LN is less than MN. Prove MN plus LN is greater than LM. MN plus LM is greater than LN. LM plus LN is greater than MN. Notice that MN is greater than LN and that MN is greater than LM. Then it's obvious that MN plus LM is greater than LN and MN plus LN is greater than LM are true. Hence, what remains to be proved is the third statement. LM plus LN is greater than MN.
Hence theorem or SAS inequality theorem. If two sides of a triangle are congruent to two sides of another triangle, but the included angle of the first triangle is greater than the included angle of the second, then the third side of the first triangle is longer than the third side of the second.
Inverse of the hinge theorem or SSS inequality. If two sides of one triangle are congruent to two sides of another triangle, but the third side of the first triangle is longer than the third side of the second, then the included angle of the first triangle is larger than the included angle of the second. So, this is the example of the inverse of the hinge theorem or SSS inequality. If BC is greater than YZ, so this is the example of the converse of the hinge.
So, the inequality theorems in one triangles are Triangle Inequality Theorem 1, which states that if one side of a triangle is longer than the second side, then the angle opposite the first side is larger than the angle opposite the second side. Triangle Inequality Theorem 2. It states that if one angle of a triangle is larger than the second angle, then the side opposite the first angle is longer than the side opposite the second angle. So it is just the converse of Theorem 1. We have also Triangle Inequality Theorem 3, which states that the sum of the two sides of a triangle is always greater than the third side. And we have exterior angle inequality theorem. It states that an exterior angle of a triangle is greater than either of its two remote interior angles. We have also inequality theorems in two triangles. The Hence theorems, which states that if two sides of a triangle are congruent to the two sides of another triangle, but the included angle of the first triangle is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the second triangle. And we have also the converse of Hence theorem, also known as the SSS triangle inequality theorem. It states that if two sides of a triangle are congruent to the two sides of another triangle, but the third side of the first triangle is longer than the third side of the second triangle, then the included angle of the first triangle is larger than the included angle of the second triangle. Now, let's have exercises.
Inequalities in one triangle. Triangle inequality theorem 1. SS to AA. If one side of a triangle is longer than the second side, then the angle opposite the first side is larger than the angle opposite the second side. The longest side is BR, then the shortest side is BI. Largest angle is I, then the smallest angle is R. Triangle inequality theorem 2. AA to SS. If one angle of a triangle is larger than the second angle, then the side opposite the first angle is longer than the side opposite the second side angle. Largest angle, angle S. Smallest angle, angle C. Longest side, EC. Shortest side, EN. Triangle inequality theorem 3. S1 plus S2 is greater than S3. The sum of the lengths of any two sides of a triangle is greater than the length of third side. 5 plus 6 is greater than 7, which is 11 greater than 7. 7 plus 6 is greater than 5, which is 13 is greater than 5. 7 plus 5 is greater than 6, which is 12 and is greater than 6. Exterior angle inequality theorem. The measure of an exterior angle of a triangle is greater than a measure of either remote exterior angle. By the way, an exterior angle is an angle that forms a linear pair with one angle of a triangle. Interior angle, angle ABB. Remote interior angle, angle BBB, angle BBB. This measure angle ABB is greater than the measure angle BBB. Measure angle ABB is greater than the measure angle BBB. Inequalities in two triangles. Hinge theorem or SAS inequality theorem. If two sides of one triangle are congruent to two sides of another triangle, but the included angle of the first triangle is greater than the included angle of the second, then the third side of the first triangle is longer than the third side of the second. If side AB is congruent to side BE and side AC is congruent to side BF, but the angle A is
congruent to two sides of another triangle, but the third side of the first triangle is longer than the third side of the second, then the included angle of the first triangle is larger than the included angle of the second. If side GH is congruent to side KJ and side GI is congruent to side KL, but side JL is longer than the side HI, then the angle K is larger than the angle G.
So that's it. Let's have a quiz. So in this quiz I use Dakota software. So let's take this quiz. Let's try if you know how to answer by applying the triangle inequality theorem. Let us find or name the longest and the shortest side in each triangle. So in the given, so we have angle W is 60 degrees, angle Y is 85 degrees, angle X is 35 degrees. What would be the longest side? So, what's your answer? Yes, the answer. The longest side is side WX and the shortest side is WY. Let's try another. So this time we have the given sides. Side left. So TU is 15, UV is 12, PV is 17. So what would be the largest and smallest angle in the triangle? The answer? We have angle U is our largest because it is opposite to the longest side, which is 17, and our smallest angle is angle T because it is opposite to the shortest side, which is 12. Okay, let's have number 2. Now, kindly give the order of the sides of each triangle from shortest to longest. Given, angle Y is 68 degrees, angle X is 65 degrees, and angle Z is 47 degrees. What would be the answer? So we have YX, ZY, and ZX. Our shortest is YX because it is opposite to the smallest angle, which is 47. Next to it is ZY. ZY is opposite to the second largest angle, which is 65 degrees, angle X, so ZY. And the last one would be ZX. ZX is opposite to the largest angle, which is 68 degrees. Now, let's have this one. So, for this time, the given are the sides. So we are going to order the angles from smallest to largest. So we have YX is 21, so W is 11, YW is 16. So what would be the answer? Let's see. Okay, that's the answer. So we will start with angle Y, since angle Y is opposite to the side 11. Next to it is X, angle X, it is opposite to 16. And our largest angle is angle W, since it is opposite to YX. Next, so let's have state if the three numbers can be the measures of the sides of a triangle. So it be the measures of a triangle, or the sides of a triangle. 10, 5, 7. How are we going to know? So we are going to apply triangle inequality theorem 3. Okay, so the answer would be yes. Yes, since we are going to add two numbers, it is greater than the other number. So, but for you to be able to be sure, so we are just going to compare it with the longest side. So the longest side is 10, so we are going to add the two remaining sides, which is 5 and 7. And 5 plus 7 is 12. So 12 is greater than 10, so that's why we can form a triangle. How about this one? 6, 20, 12. Can we form a triangle from these measures of the sides? 6, 20, 12. Yes or no? The answer would be no. Why it is no? So again, we are going to look for the longest side. The longest side is 20. We are going to compare that one to the sum of the remaining sides. 6 plus 12, and the answer is 18. So 18 is less than 20. Again, the sum of the two sides should be greater than the third side. How about this one? 11, 12, 10. I know you know now how to answer this one. So, it's a yes. We have the longest side is 12. So the remaining is 11 and 10. 11 plus 10, that would be 21. It is really greater than 12. Okay, we have another one. Okay, how about this one? Two sides of a triangle have the following measures. Find the range of possible measures for the third side. What would be the range for the possible measure of the third sides? We have 7, 11. What would be your answer for this one? So again, when we speak about range, so that would be a number or the possible numbers of the third side, the possible measures. So the answer would be, so the number should be less than 4, greater than 4, but less than 18. So meaning the measures will start from 5 up to 17. Okay, so because 5, if we are going to add 7 plus 5, that would be 12, and it is greater than 11. 4 is not allowed, since if we are going to add 4 by 7, that would be 11. So again, by triangle inequality theorem 3, it should be greater than, and it should not be equal. And it will not also be greater than 18 or 18, because if we are going to add 11 plus 7, that would be 18. So if we are going to compare it to 18, so is it greater than or not? So it is not. So to be sure, or to make it easy for you, what you are going to do is just you are going to subtract minus 7, and that is 4. And for the higher range, you're just going to add 7 plus 11, and that is 18. Okay, so let's try. If you know now, how about 10, 6? What would be the possible measures of the third side? So it would be easy now. The answer would be, so the possible measure is greater than 4 but less than 18. So meaning it would be from 5 to 15. Okay, so it's same concept as I stated earlier. So 10 minus 6, that would be 4, and 10 plus 6, that would be 16 again. So 4 is not allowed, because if we are going to add 4 by 6, that would be 10, and as I said, it should be greater than 10, the third side. And for 16 also, 16 cannot be a measure, since if we are going to add 10 plus 6, that is 16. So a side of 16 is not allowable. Okay, how about this one? I think this would be the last. 7, 12. What would be the answer? The answer would be, okay, so it is greater than 5 but less than 19. How about this one? So find the measure of each angle indicated. Can you find the other angle? The answer is, oh no. So the answer would be 61. Why 61? So you are just going to subtract 146 minus 85, and the answer is 61. Why? Again, based from exterior angle theorem, well, our lesson is all about inequality. So it would be the remote interior angle should be less than the exterior angle. But for you to be able to find that one, we are going to apply the exterior angle theorem. It states that the sum of the remote interior angles is equal to the exterior angle. Okay, so again, to find how did we able to find 61, as stated by my student a while ago, the exterior angle will form a linear pair. Okay, it cannot be an exterior angle if it will not form a linear pair with the interior angles for the interior angles of the triangle. So we are going to apply that 146. So 146. So 180 minus 146, the answer will be 34. 34 plus 118 is 40, as I stated a while ago. Next. No more. I think that will be all for our quiz. Okay, so let's see. Thank you for watching.